you might know that the integral of 1 over the square root of 1 minus x squared dx is the inverse sine of x, but you might not have understood why. And in this video we're going to show exactly why that is the case using something called trigonometric substitution. So if you've ever heard of U substitution, trigonometric substitution is essentially its trigonometric analog. There's one big difference that I'll point out. In U substitution, you define U as some function of x, so let's call that f of x, and then you find du. So du is just going to be f prime of x dx, right? And you go ahead and plug in, you plug all the stuff in, and then you get an answer in terms of u, and then you substitute x back in for u, or you substitute f of x back in for u, and you're done. Over here, you do something that's quite the opposite. You instead of defining u in terms of some other variable, you define x in terms of some other variable, and when you're dealing with trigonometry, as you might guess, the usual variable, the choice of variable is theta. So we'd have something like x equals some trigonometric function t of theta, and so d of x will just be t prime of theta, and then of course a d theta. That's the main procedure that we're going to follow, so I'm going to leave that up there. And when we're thinking about what function to use, there actually, when you get deeper into trigonometric integration, you'll see that there are rules for this. But over here, if you just think about it, you see 1 minus x squared, right? You want to simplify that, right? You want something that's easy to work with. So you don't want something like 1 minus tan squared x, but you would be happy with something like 1 minus sine squared, not x, it should be theta. So 1 minus sine squared theta would give you cosine squared theta. You're taking square root of that, so that becomes nice and easy. It's just cosine of theta. Likewise, if you did cosine of theta, right? If you did x equals cosine of theta, you get 1 minus cosine squared theta, which is sine squared theta. You're taking the square root, so that will give you just sine of theta, absolute value of sine of theta. So we're going to pick one of those two. And in this video, what I want so you can use either of them, right? And what you'll see is that you'll get the same answer regardless. What I want to do over here is take x as sine of theta, right? And the reason I'm doing this, I just prefer it because the derivative of sine of theta is cosine of theta, right? It's as opposed to cosine of theta, which would have a derivative of negative sine of theta, right? I don't want to get extra negative signs involved. I'm happy with just positive ones. So that's what I'm going to stick with. So d of x is equal to cosine of theta, d theta. And now we can go ahead and plug this in into our integral. So you just have the integral of 1 divided by the square root of, and over here we're going to put in 1 minus sine squared theta. Over here we're going to have cosine of theta, d theta. We can simplify this a little bit. What does the denominator become? Well, that's nothing but 1 over, so the numerator is 1, the denominator is the square root of cosine squared of theta, which is just cosine of theta.